Welcome back to my class. In our last class, we have seen series and parallel connection between passive elements in electrical network and how to simplify those electrical networks where we have those types of connections. Now, in electrical network, we have another two types of connections like star connection and delta connection between three passive elements. And when simplifying those networks, we may sometimes see that if instead of star, if those three passive elements were connected in delta, then it would have been easier for us to simplify that electrical network. So how to convert that particular star connection to its equivalent delta connection, or maybe vice versa. Suppose if we have delta connection, and if that delta connection we want to convert into its equivalent star connection, then how we can do that. Those theories we will be learning in today's class, and we will be solving also a few numericals based on those concepts. So let's start the class. First, we have to see what is a star connection and delta connection. Star is a type of connection where we have three branches or three phases in case of three-phase electrical system. And these three branches, one end of these three branches are connected to a common point, which is called neutral point. And the other end of these three branches or three phases are connected to the some other part of the circuit. As I said, that this common point is called a neutral point in case of three-phase star connected electrical circuit. This star connection is also sometimes called Y or T connection. As you can see here, we have three resistors. This is a purely resistive circuit. We have these three resistors connected, and how they are connected. One end of this resistor RA is connected to this neutral point, and with that neutral point, one end of this resistor RB is connected, and with that neutral point or common point, one end of RC is also connected. So this forms a star connection. Now these are the different orientations of star connection. As you can see, this looks like Y. So this sometimes the star connection is also called Y connection. Also, if we connect this three resistors this way, then this type of connection is also star connection, where this is the neutral point, and this connection looks like T, alphabet T that we know. So this connection is sometimes also called T connection. Now these are also different orientation, as I said, of star connection. Now if we come to the delta connection, delta is a type of connection where this, you can say, is a connection between three phases or three resistors, where these three branches or three resistors or three phases forms a closed loop or mesh type of connection. So here, as you can see, one end of this resistor R1 is connected to the one end of R2, and the other end of R2 is connected to one end of R3, and the other end or second end of R3 is connected to the other end of R1. So altogether, these three resistors or three branches, they form a closed loop or mesh, and this looks like a delta. As you can see, as we know the structure of a delta or the symbol delta. These are different orientations of delta connection. As delta connection is also sometimes called as pi connection. As you can see here, this is also a closed loop between three resistors or three branches, and this looks like a Greek letter pi. So this is also sometimes called pi connection, and this is though it looks like a circle, but this is also a closed loop or mesh between three resistors. So this is also our delta connection. Now in case of delta connection, there is no concept of neutral points. So in case of three-phase delta connection, delta connected electrical circuit or system, there will be no concept of neutral point. So this is the basic of star and delta connection. Now we'll now in an electrical circuit or network, there may be a complex network of different resistors or SE component, where we need to simplify that circuit, and we need to find out the current through a particular element, or maybe the voltage drop across an element, or maybe the what is the current that is supplied by the energy source or the voltage source that is connected in that electrical system. And while simplifying that circuit, we may see that there is a star connection between three components, maybe DC component or AC component. But if they were connected in delta, then it would have been easier for us to simplify that circuit. Again, in there may be in an electrical system or circuit, when we simplify that, there may be a scenario or circumstance where we may see that three components are connected in delta, but if they were connected in star, then it would have been easier for us to simplify that circuit. So that's why when in case of electrical network, sometimes we may need to convert a star connected to a star connection to an equivalent delta connection, or the vice versa. Maybe the three components are connected in delta, but we may need to convert that delta connection to an equivalent star connection. So that the next thing that we will learn is how a star connected elements can be converted to an equivalent delta connection, or the vice versa. Now here the circuit or the connection that is drawn in green is a star connection, as per the concept of star that we have learned just now. This is a star connection, so that is drawn in green. And what we will be doing here, if that needs to be converted to an equivalent delta connection, then what will be the values of that delta connected components. Now this is the neutral point of that star connection, and these are the three other endpoints, A, B and C. Now the delta equivalent delta connection that will be formed for this star connection, they will be between A, B and C only. So this between A and B, this is the resistor R1, between B and C R2, and between C and A, this is R3. Now this R1, R2, R3 are the resistors of that equivalent delta connection. Now we have to see that what are the values of R1, R2 and R3 in terms of RA, RB and RC. Here I am not going by the derivation of this conversion, because finally when we will be simplifying, we will be converting a star to an equivalent delta. Fine, we have to use the formula or the relationship between this RA, RB, RC and R1, R2, R3. So in case of the equivalent delta connection, in case of delta connection, the resistors are R1, R2 and R3. So finally, when we will be expressing R1, RA plus RB, and then there will be a third part, and that will be RA multiplied by RB upon or divided by the last register that we have in that star connection, which is RC in this case. So this is how we can find out R1 in terms of RA, RB and RC. Similarly, if we go by the same pattern, then R2 can be found out, like for R2 these opposite resistances are RB and RC in this delta connection. Then it will be RB plus RC. It will be RB multiplied by RC divided by the last register that we have in that star connection, which is RA in this case. And similarly, now you can understand that what could be RC. RC will be then RA plus R3 will be RA plus RC, RA multiplied by RC divided by the resistance which is left, and that is RB. So this is the relationship of the resistors which we have in that converted delta connection in terms of the resistors that we have originally in the star connection. Now in the next conversion, we have to convert a delta connection that we have in our original circuit. But if those circuit elements were connected in star, then suppose it would have been better for us or easier for us to simplify that circuit. So what we will do, we will convert that star delta to star. Now the elements or the resistors that are drawn in green, they are connected in delta, as now you understand what by the concept of delta connection. And now we have to convert that to an equivalent star. So the resistors that are drawn in red, they are basically connected in star. So they will be connected between these three endpoints only, A, B and C, and in case of star there will be a neutral point. Now we have to see what are the formula when we will be converting the or in the registers that will be there in the converted circuit, in the converted delta connection. So here in case of star, the resistances are RA, RB and RC. So we will be finding out the values of RA, RB and RC in terms of R1, R2 and R3. So RA will be, again I am not going by the derivation, I am writing the final relationship of formula. So RA will be in this case the resistances that we have on the both the sides of that resistor. So here in this case, in case of RA, they are R1 and R3. So here the formula will be R1 multiplied by R3 divided by the summation of all the three resistances that we have in that delta connection. So that means R1 plus R2 plus R3. Similarly, now if we want to find out RB, then it will be the resistances that we have on both the sides of that RB. So they are R1 and R2. So here in the numerator, it will be multiplication of R1 and R2, then divided by it will be the summation of all the three resistances which we have in the delta connection. Now the last resistance in the star connection that we have is RC. So RC, now you can understand what will be the RC, that will follow the same pattern. So in case of RC, the resistances on both the sides are R2 and R3. So in the numerator, it will be R2 multiplied by R3, and then in the denominator, it will be again the summation of all those three resistances, R1 plus R2 plus R3. So we have to remember this two sets of formula of conversion between two types of connections, star to delta and delta to star. Now we will see next electrical circuit where we will have this type of connection, and we will simplify that will be based on this conversion. So this is the circuit where we have multiple resistors and we have a voltage source. Finally, we have to find out that how much current is flowing through this 2 ohm resistance or through ohm resistor. So 2 ohm resistor means basically the current or the main current that is supplied by this voltage source, 10 having value 10 volt. So that current we have to find out. So if we want to find out the main current which is supplied by this voltage source, so we have to simplify this circuit, and finally we have to, instead of where we have 4 plus 4 8 10 and then 11 resistances, so instead of having 11 resistances, finally in that final or simplified circuit, we will have only one resistance, and that will be the equivalent resistance of the whole circuit. And then there we will have one voltage source, one resistance, and easily we can find out the main current that is applied by that voltage source by applying Ohm's law. So what the important thing is to simplify this circuit and to reduce the number of resistors from this circuit. Now if we look at this part of the circuit, here we can see that this resistor which has the value 0.33 ohm and this resistor having resistance value 0.67 ohm, they are connected in series. We know the when two resistors are connected in series, how we can evaluate that. So these two are connected in series, and simply if we go by the concept of series connection, then the equivalent resistance of that series connection will be simply R1 plus R2. So these two resistance values will be added, and 0.33, 0.67, if we add them, then the equivalent resistance value will be 1 ohm. And in the simplified circuit, instead of having these two resistances, there will be a single resistance. So we can imagine that in that simplified circuit, we don't have this resistance, and we have one resistance there, and value of that resistance will be 1 ohm. I'm not drawing that simplified circuit, just imagine that we have in the simplified circuit in between these 2 points, now we have only one resistance and the value is 1 ohm. Now if we come to the other part of the circuit, here also we have these two resistances having the same type of value, 0.33 and 0.67 ohm, and they are also connected in series. So going by the same concept, their equivalent resistance value will be summation of these two values, and again the value will be 1 ohm. So we can again imagine that in the modified or simplified circuit, we will not be having two resistances. Instead of that, we will be having only one resistance, and the value of that one resistance will be 1 ohm. So now we have reduced we have simplified that circuit where we have reduced the number of resistors by 2. Now if we look at this part again in the circuit, as we can see here, this register and this is basically a shorted path. We don't have any register here now, and similarly on the other end, in the modified circuit, we don't have any register here also. So here we have one register here, and this register, if we focus on only this part of the circuit, we can see that these three registers are basically form a closed path or loop, and they are basically connected in delta. And also on the other side also, if we analyze that part, then also we can we can say that these three registers are also, they also form a closed path or loop, and they are also connected in delta. So here instead of delta, if these three registers, suppose they were connected in star, then it would have been easier for us to identify. Why? Suppose if we draw the equivalent star connection between them, then it will look like this. So here we'll have one register. So here, as we can see, if suppose this delta connection is converted to an equivalent star connection, then in the modified circuit we will not have these three resistances anymore. Instead of that, we will be having this connection. Now this register is connected with this register. Again, in the bottom part of the circuit, we will not have these resistances. Instead of that, we will have this star connection. So if we now focus on this part of the circuit, we can find that this register, and this register, they are connected in series. Similarly, this register, and this register, they are also connected in series. So easily we can add their values, and we can, instead of having three resistances, we can represent that this part of the circuit by only one resistor. So this way we can reduce two resistances here from this side. And again on the other side, if we focus, then again, since they are connected in series, so they will be simply added, and instead of having three resistances, there also we will be having only one resistor. So instead of having six resistances, we can represent this part of the circuit by two resistances. And then we will see the next part, that how we can reduce some more resistances. So before that, we have to find out what are the values of these resistors, and then we will see step by step approach. So this is the advantage why here, what is the reason why we are converting this delta to an equivalent star connection. So if we go by the method, the formula of delta to star connection, then so this value will be the, in the numerator it will be multiplication of the resistances that we have on both the sides of that resistance. So it is 1 ohm here and 1 ohm here. So it will be 1 in the numerator, 1 multiplied by 1, and then in the denominator what we had was, it was the summation of all the three resistances. So from delta to star, say suppose in case of RA, it was R1 into R3 divided by R1 plus R2 into plus R3. So here also, if we want to find out the resistance of this converted star connection, then it will be this 1 ohm multiplied by this 1 ohm divided by 1 plus this 1 ohm. It is 0.33 ohm. Similarly, if we want to find out the value of this resistance, then it will be this 1 ohm into this 1 ohm divided by 1 plus 1 plus 1 ohm. So it will be again 1 by 3 or 0.33 ohm. And since the values of these three resistances are same, which is 1 ohm, so again if we find out the value of this resistance, that will be 1 by 3 or 0.33 ohm only. So the values of these three resistances are 0.33 ohm, and this will be again 0.33 ohm. And if we come to the other side of that circuit, again we find that the resistance values of the delta connection that we had in the original circuit, so their values are also 1 ohm, 1 ohm and 1 ohm. So if we find out the resistance values in the converted star connection, they will be having again the values 0.33 ohm. If we draw the modified circuit, it will look like this. Now in the modified circuit, what we can see here, this resistor between this point and this point, if we analyze the right side, then this resistor and this resistor, they are connected in series. So what will be their equivalent resistance? That will be summation of all these resistance values. And if we analyze this part of the circuit of the connection between these 2 points, again this resistor and this resistor, they are also connected in series, and since their values are same, so their equivalent resistance will be again 1 ohm. So this side 1 ohm, this side also 1 ohm. So the modified circuit now will look like, where the resistance value of this resistor will be 1 ohm. Also the resistance value of this resistor will be 1 ohm, that we have already found out, this resistance value and this resistance value. And also we have this resistance where the value is 0.33 ohm, that we have already found out, and this value is also 0.331 ohm, and this was the 2 ohm resistance that we had in the original circuit, and this was the voltage source 10 volt. Now in the modified circuit, where we have now in total 5 resistances, we started with 4, 8, 10, 11 resistances. Now we have in the present circuit, we have 5 resistances, so we have already reduced by 6 resistances. Now we can see this 1 ohm resistance and this 1 ohm resistance, they are connected in parallel. So we know how, when we say that two components or two branches are connected in parallel, their endpoints are common. So this 1 ohm and this 1 ohm, since they are connected in parallel, so their equivalent resistance will be their multiplication of their individual values divided by the summation of their individual values. So it will be 1 by 2, that means 0.5 ohm. So that means now we can think this way, that instead of having these two resistances, now in the modified circuit we will be having only one resistance, and the value of that one resistance will be 0.5 ohm. So now if we analyze further this circuit, we can find that we have between these 2 points and this point, which are the end points of this voltage source, in between these 2 points, the resistances that are connected are 2 ohm, 0.33, 0.5 and 0.33 ohm, and these 4 resistances are connected in series between these 2 points. So their equivalent resistance will be just the summation of all these individual values. So it will be 2 plus 0.33, then plus 0.5 plus 0.33, and this value will be 0.66, then 1.16, so it will be finally 3.16 ohm. That means in the final modified circuit, we will have one voltage source and we will have one equivalent resistance of the whole circuit, and that value of that resistance is 3.16 ohm. and the value of that voltage source is 10 volt. Now if we go by Ohm's law, the main current will be V by the equivalent resistance of that whole circuit, and that is 10 divided by 3.16. so if that value will be 3.1645. So this is the main current which is supplied by the only voltage source that we had in the circuit, and that current will be flowing through this 2 ohm resistance, because these two and all other three resistances, they are connected in series, and we know in case of series circuit the current that flows, that is same through all the components which are connected in series. The current remains same, and that's why the whatever current is flowing through this equivalent circuit, since this is the equivalent resistance, since this is the equivalent resistance of all these four resistors or resistances which are connected in series, so what current will be flowing through this resistance, the same current will be flowing through this all these four resistors. So that means that same current will be flowing through this 2 ohm resistance value or resistor. That means that is the which was expected from us, the current which will be flowing through this 2 ohm, and the answer is 3.1645. So this is the way how in an electrical circuit where we need to simplify the circuit which had several elements, maybe DC component, maybe AC components, but we need to simplify, and we see that if three components are connected in star, but if they are connected in delta, then it would have been easier for us to simplify. This way we can use the concept of star delta or delta star connection, and we can easily simplify that circuit. So this is the end of the class. Thank you.